Clouds. So here we go.
That is not a cloud, that is the dust of extreme God's face.
Yeah. Alright, so that's definitely a cloud. Okay, that's a pretty big cloud. So I have some other cloud things I want to show you guys here. So we've already saw that one. We'll say goodbye to that.
Good Lord.
Now, I'm not sure if you guys are aware of this, but we had different wind patterns throughout the globe.
That's cool.
What's a giant black spot? What's that?
Hurricane.
Oh.
Alright, so what do you guys notice about the wind patterns?
They're very consistent.
They go right
They're
on.
consistent. Like they repeat.
They go right on the top and bottom and left and middle.
Alright, so yeah, if we follow this right here, you can see how these kind of angle up and to the left at the equator. If you're coming from the south, up and to the left. What about from the north? Down into the left as well. So this is called a conversion zone because we're converging the air down at the equator. That fits perfectly with the equator. Now, the next level that we see here and here, these are called the trade winds. And notice in the north, our trade winds move us to the east. And again, we move to the east down here. But then, what do you notice at the poles? It's kind of hard to see this, but the poles are actually, again, moving back to the west at the polar regions. So we do have these sequences of wind patterns. Some we're going to look in more detail at tomorrow. I thought it would be important that you guys see that. I don't think a lot of you guys actually realize that. And let's see. And then this is kind of important. Remember we went outside, we talked about clouds and how they form? What do you notice about the bottom of all these clouds? And why are they flat? As the air is rising, why do all the clouds form at the same height?
Because there's a layer above it.
No? So let's say it's humid here. The air starts to rise. What does it start to do? Get colder. That bottom of that cloud, that's your dew point. That's the altitude at which the water condenses and becomes a water droplet again. And so that's how we get our clouds. So when we talk about clouds, there's some really basic information you guys should know. Remember we talk about dew point. And what is the dew point?
262 volts.
It's a temperature, I'll tell you that much. It's a temperature, but it's a temperature at what?
207.
No.
Am I even close?
What happens at the dew point? Melissa, stay with us here. What happens at the dew point?
Is that where the evaporation condenses?
Yes, that is when the temperature at which water vapor condenses to water droplets. You should write that down, guys. I shouldn't be the only one writing it. Now, in order to condense, remember we talked about the fact that water must have a surface to condense to. And we saw that just the other day. We did the experiment with the jar, the candle. You guys saw the fog that got inside of the jar. That's because that water vapor needed a surface to adhere to. And so that's your condensation nuclei. Now, let's go back and watch that video again. All right, so we have these clouds, and we're told that the clouds form when the air rises to a point at which it finally condenses. Well, how does the air rise? How do we even get that air up there? You guys want to think about this for a minute. How do we lift air? Are you going to take air from the ground and move it?
The sun makes it really hot, so it evaporates.
All right, so we can have a convectional lift. So we can have the lift due to convection. And then there's another way in which we call it, and that's also orographic lift. So we need to write these down. Basically, we have two ways of lifting the air. We have orographic lift, and we have what we call frontal lift. So we have orographic lift and frontal lift. And orographic basically means mountains. It's when the mountains force the air upward. And that's what you need to know for that. Orographic is where you have landforms that force the air upward. And if you look at this graphic, it kind of makes sense as to how we get that up there. You have warm, moist air coming off an ocean or a large sea, and it comes across the land. There's this mountain range. So instantly that air gets lifted up, it instantly condenses, and we have a lot of rain. So once it rains here and the air keeps going, what happens to its moisture content? Okay. Great. So let's ask that again, a different way. What mountain range do I have here? Rocky Mountains, okay? Seattle. Kind of green, right? It's actually what we would call not a tropical rainforest, but it's still a rainforest. A lot of the American Northwest is a rainforest, yeah, because you get a lot of rain. Okay, it's just not tropical. But after those Rockies, which are pretty tall, and the air comes across the ocean, so you get a lot of rain on this, what we call the windward side. So this is the windward side, because, well, that's where the wind's coming from, windward. And all that moisture gets dropped on the windward side. So what features do we have just east of the Rockies?
Is it like dry?
Yeah, very dry. It's all over deserts. Guys, that totally makes sense if you think about them just for 30 seconds.
And when the clouds move, they don't have any more.
All their moisture is gone. So when you look at the world's greatest deserts, take Australia. In Australia, instead of the winds going this way, they're actually going to the west. There's a slight little range right here, right on the west coast of, on the east coast of Australia. And when that wind comes off the Pacific, all that rain gets dropped right here. You have this beautiful rainforest out on that eastern edge of Australia. But what sits in the body of Australia? A gigantic desert. And that's because all that water gets dropped on that eastern seashore. And so that's one of those things that's really important when we look at our world's deserts. Take China. We get monsoons that come up from the Indian Ocean. They come up straight through India and Nepal and Bangladesh. So a lot of monsoons. Here, you guys have heard of the monsoons before from that side of the world. They had wet and dry seasons because of the monsoons. But yet, what range is sitting right here? What set of mountains is sitting right here? The Himalayas, right? And then we have the Gobi Desert just beyond the Himalayas. And it's all because of the orographic lift. That's all related. And then we have frontal lift. Now in frontal lift, it's very similar. But in this case, what we have is a difference in temperature. Again, think about densities, warm air versus cold air. So in cold air, it's more dense. So as the warm air and the cold air starts to come together, the warm air will slightly begin to rise up over the cold air. And so that's indicative of a frontal lift. We had the same thing if you had cold air, it would rapidly force that warm air up and over. And we talked about that yesterday with thunderstorms. That's called a frontal lift. So if we look at these from a video perspective, so this is an example of a frontal lift. Let's go back. Oh, that's orographic lift. So right here, you can see where the starting to rise. Hey, come on now. So this is the rise due to frontal lifting, and then right here you have the mountains. It's going to force that air upward, and it's going to create the clouds. That's called orographic lift. So right here we have frontal lift. We have the warm air that's coming up over the cold air, and now we have orographic lift. All right, any question on those two ways that we can raise the air? So again, it can be lifted because of landforms, or it can be lifted due to difference in temperatures.